welcome back. I did not win the whiskey, so does anyone have any questions? Of course, he's standing like right there, like just staring at me going. Anyways, I lost it within like the last 10 seconds. Anyways, I did win the maple syrup though. Dan, did I win the maple syrup? I'll be doing maple syrup shots back to Vermont tomorrow. Anyways, thanks for sticking around for this presentation. I'm going to give you 100% on this one. And actually, Aaron has alluded to this a little bit. We heard a little bit about this in our last topic. So there's a really cool tool out there that was shown to the IMETs a couple of years ago in Boise, the Evaporative Demand Drought Index. So I'm going to show you a little bit about what that is and how we can utilize it in our operations. For just a minute, we heard all week how what a slow season it was nationwide. This is my IMET laptop setup last year. Basically just sat in the cubicle. I never got out on an assignment. So I was pretty bummed out on that. This was 2018. No, you can see that. Anyone know what Uncrustables are? Okay, so Uncrustables are like the nastiest thing you could ever put in your body. Except when you're on a fire assignment. They are fantastic. We're looking at weather all day. We're doing briefings all day. Ops is coming in. Everybody's coming in talking to you. It's really busy. Around 4 o'clock is when you wind up having to do the planning meeting. So somewhere in that mid-afternoon time period, you just need a little something extra. So the team I was with in Northern California in 2018 saw me stuffing a bunch of Uncrustables around mid-afternoon in my mouth. So every day I'd come back from the field and they just pile those bad boys up on my computer. And they really worked out great. Why is this relevant? Why am I even talking about this? Well, we've had a busy week, right? And it's kind of that mid-afternoon time period. Anyone feeling like they need a little something right now? Anyone? I got some Uncrustables here. Anyone grape or strawberry? Raise a hand. Otherwise, I'm just chucking them out there. There, right there. Anyone over here? Oh, come on up, John. Oh, sorry. It's still good, trust me. So we have actually in the IMES, and I'll start my presentation. In the IMES program last year, we started the 2019 Uncrustable Challenge, because there's grape Uncrustables, strawberry, honey, and Nutella. So we had a thing going where if an IMET got one of each at their incidence, they would become king or queen crusty for the year. Unfortunately, we didn't have a lot of IMETs, so we'll have to continue that for next year. So, all right. Evaporative Demand Drought Index. What I first want to just show you on this map is the scale. Many of you are probably familiar with the U.S. Drought Monitor. All I want to tell you right now that you need to know, the Evaporative Demand Drought Index, the scale on the bottom in terms of the drought categories mimics what you see with the drought monitor. So when you have a category ED4, that's exceptional drought, and that matches exactly with what the U.S. Drought Monitor is. ED3 is extreme drought, so the colors are exactly the same. By the way, 2 best things a meteorologist does: point to a weather map and collect a paycheck. Okay, so what is the Evaporative Demand Drought Index? It's an experimental tool that can serve as an indicator of both rapidly evolving flash droughts, which we heard Aaron talk about, that develop in a short period of time, and also sustained droughts that develop over a longer period of time. Now, what goes into the Evaporative Demand Drought Index? Just some simple variables near the atmosphere's surface. It's temperature, humidity, wind speed, and solar radiation. That's all that goes into it. The U.S. Drought Monitor has a lot more variables that go into it. All right, and Aaron kind of touched upon this as well. Unusually high evaporative demand leads to moisture stress on the land surface. which affects live and dead fuels and ultimately leads to drought, even when precipitation has been near normal. So you could have an event where you have precipitation, maybe you get a tenth to a quarter inch of precipitation, and then all of a sudden you start getting warmer, drier, windier, sunnier conditions. And that's what removes that moisture. So your evaporative demand increases, which means things start to dry out. So when we start to get these pattern changes, even though you've had the precipitation, it does not take long. And I've been on plenty of assignments out west where we will have gotten some precipitation, but things just are so dry when the air mass comes in, it is so dry, and it just negates all of that because of this evaporative demand. You can quickly get back into or trend towards drought conditions. And of course, once that process starts, then what happens? The soil, the ground, all starts to dry up. So the air just above the surface gets warmer and drier. So you start feeding onto that drought, and that's what kind of starts that process. So it doesn't take much to get this. So being able to see what the evaporative demand is can help us maybe signal a faster onset of drought in drying conditions. And again, from a fire behavior perspective, if we're seeing warmer, drier, windier conditions, we're seeing those live and dead fuels drying out quickly, what does that lead to? Fire, right? Gotta show some fire pictures. 2018, when I was down in all those Uncrustables, I was on the HERS fire in Northern California up near Mount Shasta, which is Interstate 5 on the left. That's September 5th when the fire broke out. The upper right-hand corner, you can see, it's a satellite image, you can see the column. The column developed, went up 40,000 feet. And then the little colored dots just shows the heat emanating from that particular fire. You can't see it on the screen. Again, point to weather map. But right next to these colors is actually the fire perimeter for the HERS fire that I was on. It's 95% contained. New team is coming in. Our job is essentially done. We're about ready to go home. And what happens? Because it had been getting warmer, drier, windier, everything that we wanted to see. Car driving along Interstate 5, spark from the car, starts a fire on the east side of Interstate 5, where our fire was. Fire starts, what happens? A hay truck drives by. What do you think happened to the hay truck? Starts on fire. Spark from the hay truck goes on the west side of Interstate 5, which, oh, by the way, hadn't burned in 10 to 20 years. And made a run up the hill, and it did not take long to get to plume-dominated conditions. And that's Lakehead looking south towards Reading. It was crazy those next 3 days. I can't tell you how many Uncrustables I ate. Anyone need an Uncrustable? Yeah, oh, there we go. Doesn't matter. That's the beauty of these things. Audio. All right. Excellent. Okay, so now let's do a little side-by-side comparison to show you. We're not trying to tell you use the Evaporative Demand Drought Index all by itself. It still has, the U.S. Drought Monitor still has value, but we can see some of the differences where one might help in certain situations. So, if you provide added value to other drought indicators. So, the column on the left-hand side is the U.S. Drought Monitor. The first map at the top is May 1st. The last one is August 7th. On the right column, going the same time period, is the Evaporative Demand Drought Index. Kind of what I just want to point out, the top line is May 1st. So Drought Monitor on the left, if you look at the boxed area, the central part of the country, not really showing any drought at all. Where now we are starting to see some hints of drought on the Evaporative Demand Drought Index. The next row down is June 5th. Look at the Evaporative Demand Drought Index. We're already starting to see severe to exceptional drought, whereas we're now just starting to get abnormally dry to moderate drought looking at the U.S. Drought Monitor. And then you jump all the way down to the very, very bottom, August 7th, when the U.S. Drought Monitor finally picks up exceptional drought across much of the central part of the country, again, the Evaporative Demand Drought Index had already picked it up essentially 2 months prior before the U.S. Drought Monitor in this particular situation. Again, nothing wrong with looking at the U.S. Drought Monitor. There's just what goes into it, the time lag. There's some differences that can not allow the U.S. Drought Monitor to pick up on these flash droughts, and that's why I think the Evaporative Demand Drought Index is a very nice complement to the U.S. Drought Monitor. Shall we look at an example case, or do we just go home? Oh, thank you. Who said that? You? Oh, you already got it. Okay, I was going to give you another one. He's doing it. Okay, so we'll start over here. U.S. Drought Monitor on the right. This is October 30th of 2018. And then you have the Evaporative Demand Drought Index. Remember, the colors are all the same. That's valid November 1st. So it's close to the same day as possible. Let's focus in on northern and central California. Looking at the U.S. Drought Monitor on the left, you actually have no drought to some abnormally dry conditions. Whereas look at that area in north central and central California. You're already starting to see some indications of at least severe drought in that area. Let's step forward 1 week and see what it looks like. So go back to that U.S. Drought Monitor on the left-hand side. We're now starting to see abnormally dry to moderate drought conditions all across northern and central California. Look at that bullseye across northern and central California on the Evaporative Demand Drought Index. Exceptional drought pretty much across that entire area. This will be valid on November 8th, 2018. Anyone know what happened on November 8th, 2018?
Yes.
Who's the campfire over here? You want grape or strawberry?
Strawberry.
The campfire is correct, unfortunately. That was November 8th, 2018. Let me step back to this map. From a meteorology standpoint, just a little insight, I guess what my approach would be, especially with this Evaporative Demand Drought Index. A lot of times with forecasting, we'll issue flood watches, but there's days when there's a flood watch where we get minor flooding, and then there's days when we get major flooding. What are the differences? What stands out between those two? A lot of times there's similar meteorological conditions, but ultimately there's something that leads it to being a more extreme event. Same thing happens with severe weather, with winter weather, with fire weather. Is there something out there? Is there a signal, something that's kind of slapping me in the face to get my attention? And from a meteorology standpoint, again, I love seeing something that just stands out and slaps me in the face, because now that has my attention. And now I want to know, okay, I've got these exceptional drought conditions, and this is kind of a simplified thing, but what if I knew in that area there was going to be 60 to 80 mile per hour winds for 48 hours, and the relative humidities were going to go down to 5%, and they were never going to get above 15% overnight? Probably something major, right, would happen. That's the difference, and obviously we saw that in the picture because that's what happened on the campfire. 60, 80 mile per hour winds and incredibly low relative humidities over the top of an area that was considered exceptional drought. And so it kind of makes sense that you would have something like this develop. So again, from a meteorological standpoint, I'm excited to see something that, if I didn't know anything else and I was using the drought monitor, yeah, we're in drought, but maybe that doesn't give me a taste of really how dry the conditions are. And that's kind of what happened on the HERS and Delta fire. The fire behavior analysts, we knew our fire area was pretty much under control, but we knew the whole time the area around it was just getting drier and drier. And we constantly briefed the crews, be aware of what's happening around you. And you saw what happened when I showed you on can get these extreme situations. Does that play? You know, we've been just hearing how things seem to be more extreme, and a lot of times this is what we're seeing. So where do you find the Evaporative Demand Drought Index? There's actually, I have it on the website. The web address is actually on the back of these Encrustables. Does anybody want these Encrustables? I'm just kidding. I've asked Dave Prairie to write jokes for me because mine don't seem to be working. Who over here? There we go. All right. So this is the web address, and when Amanda has these presentations online, this will be in that presentation. I'll take the Encrustables out of the presentation. But this is the site, and you can actually go on there. It goes a little bit more in depth of what the Evaporative Demand Drought Index is. So you can learn some more about that. And then for some of you that were here, I wasn't here last year because of the government shutdown. But 2 years ago, the Fire Science Working Team, we had done a presentation. We actually, on the Fire Science Working Team webpage within the compact, is this northeastcompactfireweather.org. And so we have the Evaporative Demand Drought Index maps on the drought category. So let me just try to show you a couple little things on each website. Ben, I'm going to need your help here. So, on the Evaporative Demand Drought Index website, all I'm going to do right now is click on current conditions. I just need to scroll. That's not okay. So, on their website, it shows there's 2 different time scales that you can look at. You can look at the Evaporative Demand Drought Index in a monthly time frame, all the way back to 12 months, or you can look at it as a 1-week Evaporative Demand Drought Index. So there's 2 different ways you can look at it. So for example, this is the 1-month display, which is valid January 25th, so from a few days ago. But notice you've got severe drought bullseye over there in the Ohio Valley across portions of the southeast United States. What we can do in this little pull-down menu is we can select the time unit, and there it is, week or month. I'll keep it on month. And then over here, you can just go back. I'm going to go back 2 months. And now the map will kind of update. So the interesting thing, if you go back to 2 months, now a 2-month Evaporative Demand Drought Index, notice that drought in the Ohio Valley isn't quite as widespread as it was. So I was showing you in the November example how you can see conditions getting worse, getting more towards drought, but you can also look at it the other way around and seeing how maybe you were in drought and now you're starting to come out of it because you're getting quite a bit of precipitation. So for example, let's go back to the 1-month drought, and now instead of 1 month, we look at 1 week, ending on the 25th. Look at the Ohio Valley. Now there's like nothing to a little abnormally dry. So what is actually happening here, we could actually go back, and I'm going to go to 4 weeks. What does it look like the last 4 weeks? Which is essentially the 1-month map, right? So if we go back to 3 weeks, it's starting to go away. So what that's telling me was the drought was much worse a month ago, and we're actually having improving conditions in that area. So again, you can see it going, you can see ways that the drought might be improving and ways that it might be deteriorating. On the Northeast Compact Fire Weather site, which works on desktop, laptop, tablet, mobile devices, if you go to drought, on the drought outlook, I just have a side-by-side, the latest US drought monitor, and then the 1 month. And when you mouse over it, you can actually click on the link and that will take you to the Evaporative Demand Drought Index page. So again, not trying to replace the U.S. Drought Monitor, but could be another useful tool. I was talking when I was in Northern California, the Geographic Area Coordination Center up there, they've been looking at this pretty frequently over the last couple of years, and they're pretty excited about it as finding out some utility with this tool to try to capture those events where all of a sudden you're getting into these flash droughts. Because obviously we had Camp Fire, we had the Hearst Delta Fire, and of course prior to that was the Car Fire just outside of Reading. So that area was really hard hit in 2018. So that's a little bit about the evaporative demand and the drought index. That's really all I've got, except for the last two Uncrustables. Anyone? I gotta get rid of these. Anyone? Seriously. Oh, how about Mr. Whiskey over there? I'll give you 2 Uncrustables for the whiskey bottle. 2! Any questions at all? Yes.
A while ago, I heard about our new index, the hot, dry, windy index, and the issues with pressure. Is that something we can expect to see, or is that just kind of go by the wayside?
The hot, dry, windy index is what's going to get me back to the conference next year to give a presentation. That's my little job security. No, it's actually great that you mentioned this, and I know Quebec, we were kind of talking about this earlier too. There's some people that don't like the Haynes Index, and which is fine. There's value, and I can understand why there might not be value for some. But there's this new thing called the Hot, Dry, Windy Index that takes into account how hot, how dry, how unstable things are. And it's just another different way to look at areas. And again, it shows you big bullseyes that might want to get your attention. That the weather conditions are ripe for something for critical fire weather to develop. That's a great question. That's worthy of it. Oh yeah, right. Thank you, Robert. All right. If you guys aren't back next year, we'll know. But trust me, I've been needing these for a couple of years. No.
I was just thinking if you used the ground monitor to reflect the stress on trees, would it be more accurate to use this ground index to reflect the stress on trees?
I'm not sure. I'm not a forestry person to know that. I don't know if anyone might know the effects on trees, if this would be something that would have utility for that. I'm hearing some oh yeah. Did you want? I heard oh yeah.
Yeah. It sounds like a research paper for somebody. So we're going to go to break right now. Eric requested Uncrustables for break, so there's a plenty table full of them out back as well. So if you're disappointed you didn't get one, there's plenty out on the table. So we're going to take about 15-20 minutes. We'll come back in here. We do have a wrap up.